All right, so we'll pick up where we were last week. We've kind of broken down our inquiry into four major questions, the first being the existence of all the matter and energy in the universe. We spent some time talking about that, and we're doing it in a very condensed fashion. And then the kind of precise organization of the universe and how likely is that to have happened completely at random. So we talked some about that. At the end of last week, we just got into this idea of life, the initial appearance of life on Earth, kind of our third major question in my way of breaking it down. So we're gonna get into that this week. And so last week, what I just showed you is there's something very obviously unique about living things as opposed to non-living things. And so, I mean, it's not just some small difference, it's huge. So our third question then, that we have to figure out what explanation makes the most sense, all things considered, is the initial appearance and survival of any kind of life on Earth, any kind, not the life that we see now. We're coming to that. So one theory, of course, is that it was created by intelligent design, by a superior entity. Another is that it happened spontaneously, as we'll look at that. There's still not a prevailing theory for how, but there's a lot of very, very good thought that has gone into that. And another is that it was either an alien placement or a meteorite impact that carried life with it. That's not widely held, but I do want to mention it to you because there are some who hold that. All right, so we looked at right where we finished up last week. We talked about kind of what does define life, just at the most fundamental level. How can you say something is alive or not alive? Well, I went through an awful lot of people's definitions, and I really pared it down to the shortest list that I could possibly come up with of things that have to be present or things that have to be true for something to be alive. Containment, that is, you have to be separate from the environment around you, a separate organism of some type, whether it be a human body or one single cell. All right. Metabolism, the organism has to be able to use energy somehow to do what it needs to do. All right. Otherwise, no life processes take place. Synthesis, every organism has to be able to produce what it needs to produce. A lot of times that's proteins, enzymes, just whatever it may be, other things. Different cells in your body produce very different things for their function. Protection in some way, and that's kind of goes with containment. You are protected from your outside environment around you by a lot of things. One is your immune system, but even at a more basic level, your skin or your cell membrane if you're a bacteria. Ingestion of nutrients somehow. Reproduction, because if there is no reproduction, then it all counted for nothing. If you had one cell that came into existence, but then that was it, well, that would be that. And you're back at zero. So for life to exist, it has to reproduce. Organization within the thing, excretion of what it doesn't need, and that it is a totally freestanding organism. So that's the shortest list I could come up with. All of those things have to be true or be present for something to be alive. Well, and as I note at the bottom, self-repair is almost universal as well among living things. It's not strictly necessary to be alive, but it's almost universal. And the basis of DNA and RNA and extremely high complexity. There is no simple life. We now know, the more we learn, there is no simple life. Okay, so producing life from non-living material, that's pretty tall order. So as we said, opposed to creation by a superior entity, the names of these two other hypotheses that I showed you a moment ago are abiogenesis and panspermia. All right, panspermia, this was Sir Frederick Hoyle that we looked at some quotes from recently, a very noted astrophysicist who figured out about carbon atoms and what happens in the middle of stars. And there are several others that have looked at this too. What they have kind of said is, all right, we don't believe in a creator. I'm paraphrasing here, clearly, but I'm representing them accurately. Kind of like, well, we don't believe in a creator, but the appearance of life is just so incredible that there's just no way it happened by random processes. There's just no way it happens spontaneously. We just can't buy that. There's no way. So we think that it probably landed here from somewhere else in the universe. The word panspermia literally means that the seed of life is everywhere. That's just kind of what that word means. So it's floating, or there's life floating around the universe. Maybe a meteor, whatever, landed here, and there was your first simple microbial life, and so from there it evolved. So that's the idea of this. I will just say now again, I never believe in accepting or rejecting something based on taking a vote, but that's not very scientific. But at any rate, I will tell you it's generally rejected because there's no evidence for it. I mean, it's a clever idea. I'm going to give it that, but there's no evidence for it. There's no way to test it in any way, etc. It doesn't explain anything, because for that to happen, then the obvious question is, well, how did the life occur somewhere else? So it kind of doesn't explain anything. So we're not going to spend a whole lot of time on that, but I did want to at least let you know about what it is. So the other atheistic or naturalistic theory is called abiogenesis. I put that in quotes. You'll see why in just a little bit. The reason I do is it's not an observed phenomena. Okay, but it's an idea we're going to give serious attention to. All right, now I just want to let you know too, as we've said, technically this is not the same thing as evolution. People talk about evolution. You probably never hear about abiogenesis unless you're heavily into reading certain stuff about this. But the two are usually put together because, let's just say, if there's going to be life on Earth as we see it without any intervention from a superior entity, you have to have both of those phenomena. Not just evolution. Yes, evolution has to be true, or some other alternate theory yet to come. But you have to have life to start with, because even if evolution can occur, which we're coming to later, it has to start with something. Okay, you have to have something to evolve. Does that make sense? Okay, so you never really hear about that though, but this is a very big hurdle of its own. Now, usually abiogenesis and evolution are just kind of put together and kind of called the general theory of evolution, meaning, yeah, both of these things happened. That life appeared spontaneously and then evolved into what we see now. But they are totally separate things, and we're going to look at them separately because each one has its own set of considerations, evidence, etc. All right, but the bottom line is they both have to happen if you're going to have a completely naturalistic, that is, no intervention from a creator, etc., explanation of the life that we see. So what is abiogenesis? Well, what the word means most literally is the beginning of life without. The beginning of life without life, or the appearance of life from non-living material. Okay, that's what the word means. All right? Well, you might just say, well, I mean, isn't this just a well-established fact? I mean, we're just always told. Every one of the science textbooks I ever had that just said that's what happened. And it usually got about 2 sentences before it just went into, and then it evolved. So it's just, I mean, don't we just know that that's what happened? Well, let me just tell you, and by the way, I know this is going to be probably one of the things that I will condense the most, really wrestled with what to leave out here. So I know you're going to say, well, man, you didn't really cover that in detail. No, I won't, unfortunately, but I'll tell you as much more as you want and put you on to all kinds of good resources from every standpoint if you want. Okay, now some people say, well, look, we know the spontaneous generation, people in earlier times, before they had as much collected knowledge, yeah, they thought that, bad meat gave rise spontaneously to maggots and flies, and we know that's not true. Okay, but I want to, in all fairness, I am not equating this with things like that, okay? It's not fair to make fun of something, a serious theory. So I just want you to know this is not the same thing as that. This is not like, yeah, we've known for 400 years now that doesn't happen. Different thing. This deserves serious consideration, and I just want to let you know that. There is some overlap in these things, but anyway, it's much more sophisticated than just some of those early beliefs, all right? Darwin hinted at this idea Darwin initially, in his writings, believed that life was created and then evolved. All right? He kind of changed his mind on that evidently a little bit later on, and he kind of hinted at this idea that, well, maybe we don't need creation after all. Maybe it was spontaneous. And so they kind of removed some of his suggestions that creation was the initial origin from some of his earlier texts. Okay, there are some other people, some names here, if you get interested in this, that you can look up their work independently who came up with these same ideas, and numerous other proponents of this idea. And a lot of people, without really saying, okay, we think this is how it works, a lot of people just saying, in general, this must be what happened. All right? So you have an awful lot of people up until the early 1950s, and until there were things like electron microscopes, a lot of people thought cells were not very complex, that there was just really protoplasm in a cell. It was just kind of some substance. I mean, I'm not making fun of this. There was, the microscopes of the day couldn't see anything beyond that. So I can't blame people for thinking, until electron microscopes came across, and then it was almost like that and the discovery of DNA, which happened, fairly, and both of those things really knocked people back, and with, wow, we had no idea how complex this whole thing really was. So you had a lot of proponents of this until then, trying to figure out how this might have happened. Well, this is the big one that you may have heard of. If not by name, you've probably heard of this. The Miller-Urey experiment, 1952. Harold Urey was a well-established researcher, biochemical researcher, had done some just tremendously brilliant work. He had a graduate student named Stanley Miller, and Miller, I think it was really his idea. He's a very, very smart guy, okay? He kind of said, well, hey, let's figure out how this might have happened. If we're going to say that living material came from something non-living, well, we got to have some kind of a proposed mechanism for that. Let's see if we can figure this thing out. And they set up an experiment, and despite a few little problems with it, I'm going to tell you, this is good thinking, all right? It's very clever what they did, and I really respect that. Basically, they tried to recreate as best they could some of the conditions that might have existed, or as they proposed that they existed on early Earth with no life present. Okay? Bunch of chemicals on a big dead rock with some atmosphere, etc. So what they did was they mixed up a bunch of mixture. You hear about the primordial soup, etc. Okay, they tried to say, okay, what do we think might have been in that? Bunch of chemicals, bunch of organic molecules, not alive, but there's carbon, oxygen, all this kind of stuff. Okay, so what we're going to do then, they said we're going to heat that. So we kind of turn it into a vapor because there was volcanic activity and everything. All right, and we're going to put methane and ammonia in there with it because that was part of it. And we'll let it come over into this chamber here, and then we're going to put 2 electrodes in there and like a spark plug. And we're going to, kind of repeatedly just make a spark flash across that to simulate lightning, maybe, in the early atmosphere. All right? And then, we're going to let it cool back down into a liquid, and we're going to run it, and we're cycle it through again. So we're just going to keep doing this, and I don't remember exactly how long they let it run, but they, I think it was several days or maybe more. Well, actually, they drew some at several days. They drew some more, a little bit of it off for testing analysis at about a week, etc. All right, I think this is pretty clever. Now, there were a few problems in their methodology. The experimental atmosphere that they created in there, we now know is probably not the way early atmosphere was, and it was a lot more conducive to life than what we now think that it probably was. But you know what? I'm going to give them a pass on that. They tried. They took their best shot, and they did do a very carefully designed and conducted experiment. All right, what did they get? Well, they got several simple amino acids. You've heard of those. You may see some as supplements at the vitamin store. These are the building blocks, about roughly 21 amino acids that our body is mainly built from. All proteins are built from these, are different strings of these amino acids. So they got, so amino acid is a very simple biochemical molecule. And again, just like letters in an alphabet, there are a number of them that you can put together in different orders, different combinations to make different proteins. All right. So they got several simple amino acids. They also got several compounds which prevent amino acids from ever going together and into what's called nucleotides. And these were in a racemic mixture. You ever notice some things have an L in front of them, like L-arginine or L whatever when you buy vitamins? Okay, I'll show you in a second. There are L and D forms which are just kind of like right and left-handed. They're mirror images of each other. All right? If you look in a mirror, you see yourself, but it's exactly opposite, right? It's a mirror image. That's what these are. So they got equal amounts of the L forms of some of these and the D or R forms. Never mind. D is right-handed. Okay. Yeah, some of you bad memories of when you had to memorize all this stuff once before. All right. They didn't get any peptides, which would be like short strings of amino acids. They didn't get any proteins for sure, because those are long strings. They didn't get any nucleotides, things that would go into DNA. They didn't get any RNA. They didn't get any DNA. They got several simple amino acids. All right, here's what I'm telling you about some of these molecules. Chirality is just the idea that there can be mirror images, and these are the words for those. Okay, a racemic mixture is equal amounts of left and right. Well, here's the thing, though. Living organisms, almost without exception, only use the L forms. Only the L forms. They do not use the right-handed or the D forms. We don't know why that is, but that's the way it is. Only the L forms. All right. So what they did now was, here's what I showed you a minute ago. 50 years later, about 2002, somebody found their test tubes, etc., in a closet at that university. Okay? And again, my hat's off to this. Really good work they did. They thought, well, okay, let's find out if you let it sit there for 50 years. Now what do you get in those test tubes? Well, what they got was a few more amino acids than what Miller-Urey had originally identified. Again, they were in a 50-50 mixture of left and right, and they found no peptides. That is, no string. None of these joined together, even in short strings. No proteins, et cetera, et cetera. And of course, in 1952, they had not yet identified what DNA was. That came about a year later. Well, DNA and RNA, of course, are where things get really, really complicated, and even the simplest organisms use them. But let me just give you, since I'm going to really simplify this down, let me give you just a little illustration here. I don't know how many of you have ever made, bracelets or necklaces with letter beads, and so, a name or a phrase or something like that. I have never done this, but last night at Walmart, I got a bag of 300 of these. Okay, it's got all kinds of letters, and of course it has some little heart emojis, of course. Okay, let's suppose that I wanted to string a necklace or just whatever, and we pick anything. Let's just say I want it to say donuts and Diet Mountain Dew constitute important food groups. I think we could all agree on that. Okay, so let's just suppose, Jeff, can I pick on you for a second? If I can get this thing open. I tore the top but tried to keep the zipper seal intact, so it's now idiot-proof and child-proof, and that's why I can't open it. Okay, here we go. All right, Jeff, okay, you have to be careful here. I'm going to need my beads back, okay? All right, you want to put your hands out? Okay. There's 300 of these in here, and there's plenty of letters to make the important phrase that I mentioned. All right, so I'm going to shake them up good. Whoa. Okay, my fault. Not Jeff's fault. Okay. But when he doesn't get them all back in the bag, that'll be okay. How about take those and just close your hands. Good. Shake them up a little bit. Okay. Now, we can let them do that for a long time. Jeff, I want you to let me know if you come up with a necklace that says donuts and Diet Mountain. Keep going, man. Right. Okay. Donuts and Diet Mountain Dew constitute important food groups. Okay. Well, you know what's going to happen here. But now there's two major problems. Have you got it? Not yet? Yeah, you got it? Yeah. All right, there's two major problems here. One of them we're going to address later on, and that is, getting them in some kind of a useful order that says anything close to that. But right now, that's not even what I'm considering. We'll get to that later. Tell me this. Do you have a string of any sequence of letters? Or are they still a pile of letters in your hand?
Still a pile of letters?
Yeah. Why is that? There's nothing to string them together. You got to have like a thread, band, nylon line. You got to have something, because they all have little holes in them, right? Mm-hmm. Where you can thread through. So you have to put them in order, but you have to have something to string them on. Here's the idea. When you put a bunch of amino acids together, they don't form proteins. They don't form anything, because it takes a series of very highly specific enzymes to put them together and build a string of anything. Not just the right thing, anything at all. Does that make some sense? All right, so you don't get proteins. You never do. Good luck putting those back. Thank you very much, Jeff, for letting me abuse you there for a minute. Please do get them all, especially my heart emojis. I'm sure I'm going to need those.
All right.
Okay, I appreciate that. Good man. It takes, you might think of this. If you take all the teeth of a zipper and you can put them together all day long, will they ever mesh into a zipper? No, not unless you have this little mechanism that is designed to put them together exactly right. They don't. So this is the idea. Now, I'm gonna move into high gear here, and I'm gonna skip over an awful lot of stuff. You'll probably thank me for that, for not being subjected to all of it. But the thing is, every organism on this planet, even the simplest ones, if there is such a thing as simple, they all use DNA or at least RNA. And that's far more complicated than even proteins, which you don't get spontaneously. Okay, the DNA structure was figured out in 1953, and I tell you what, you talk about a revolution in biological understanding. This was certainly as big as anything that's ever happened in our understanding. You've probably heard James Watson, Francis Crick, a couple of British ones, and here's who you didn't hear about, who deserves at least as much credit as the two guys, was their female colleague Rosalind Franklin. I don't know why she wasn't the third name that everybody knows, because it was her X-ray imaging that allowed them to figure out what was going on. Interesting lady if you read her history. All right, so that's where we learned that proteins were not the most complicated thing. And it was thought before then that proteins were the most complicated thing in the cell, and that they carried hereditary information. Now we knew it was even far more complicated than that. It was unbelievably complicated. All right, now, here's the part I'm going to mercifully spare you an awful lot of what I would have said about RNA and DNA. Some of you have had to learn an awful lot of this before. Some of you are lucky enough to never have had to learn a lot of this. But you talk about fascinating stuff. When you get into the functions of this, and that there are multiple types of RNA, transfer RNA, messenger RNA, ribosomal RNA, translational RNA. Okay, there's nothing simple about this, and we're talking about even in the simplest organisms. Well, how easy is it to get RNA? Because you're going to have to get this somehow if you're going to have living things. Okay, extremely complex structure. Nobody has ever been able to duplicate it, no matter what they've done. I mean, the most brilliant biochemists on Earth have not been able, by any means, to duplicate RNA. Only living things have been able to do it. And you're cranking it out right now every cell in your body right now is running chemical reactions, producing and using RNA, DNA, etc. And nobody's ever been able to to synthesize it in a lab, even no matter what. Okay. Here's some other things about it. It cannot be formed or maintained in either water or oxygen. You expose it to water or oxygen, those will tear it apart. So it can only exist in a highly protected environment. You remember that list of things we talked about necessary to constitute life? It has no function, zero function, until and unless it is completed and in exactly the right sequences. It only uses L amino acids, like we talked about. And if you put a racemic mixture, a 50-50 mixture of L and D forms, it will shut down the whole thing completely. It only uses L forms, and it cannot tolerate the presence of the right hand or D forms, which is what you get from random reactions. It has no function unless it is very precisely ordered to produce the proper proteins and enzymes. And it has no function unless it also comes packaged along with some highly complex proteins and enzymes called replicases, transcriptases, and ribosomes. Okay? And that's just RNA. DNA, upon which most life is based, is even far more complicated than that. Far, far more complicated. Then they invented the electron microscope. And all of a sudden, what looked like a simple cell under the best microscopes with a nucleus and then just a bunch of protoplasm, what looked like egg white, they thought it was. Now it was like, whoa, we had no idea. Because this is, if you've ever taken cell biology, this is what's going on inside every single cell. Every single one is more complex than any factory ever built to produce anything. I won't even go into all of this. To some of you, it's familiar. So it became apparent that even the simplest life was unbelievably complex. All right, so I'm going to speed through this because, okay, so a lot of really smart people, though, are trying to figure out, okay, if for this to happen randomly, how could that have happened? Because we know you've got to have containment, and you've got to have RNA, and metabolism has to, we looked at some of those things, and I think you get the picture. So some people said, okay, well, maybe the RNA formed first, and then the other things fell into place. Others said, no, I don't think that could have happened. It had metabolism. There must have been some molecules carrying on some very crude metabolism, because that would have been necessary, and then the other things, fell into place around that. Other people said, no, water and oxygen would have torn it all apart. If anything ever did form, it would have disappeared immediately. There had to be containment first. There had to be a lipid membrane like our cells have. That had to be first. And then other people said, no, it happened all at once. Because you got to have it all, so it just happened all at once. So there are these different competing ideas for how it might have happened. But you understand, for there to be anything alive, all of it has to happen. Just like that list we looked at a while ago, it all has to happen or you don't have anything alive. All right, I'm going to spare you this. Talking about, this is from a documentary on the BBC, The Secret of How Life on Earth Began. I was very excited to get into this. As I went on and on, I was a little less excited. The guy who wrote it and produced it, he did do a good job of putting together what's out there. He just seemed to kind of ignore all of the gaping holes and contradictions in it. Those were somehow not quite as important. But you ought to look at this. It will give you an appreciation for some of the very truly brilliant scientific work that is being done by people trying to figure out how could this happen at random. And I'm glad they're doing it. I want to read every word of it. Because if they can figure that out, I want to know that. And if they can't figure it out, even after 70 years now of really brilliant, dedicated work. I mean, there are people that they have spent their whole careers trying to figure this out and warring with each other about, no, you don't have it right. I'm going to get it right. Okay, but let me just give you a flavor of the level of logic here. Okay, talking about maybe RNA happened first. Gilbert, one of these researchers, he said, well, the first stage of this evolution, or abiogenesis, he said it was RNA molecules performing the catalytic activities necessary to assemble themselves from a nucleotide soup. So these molecules that don't exist, very complex molecules, they performed the catalytic activities necessary to assemble themselves. I don't understand how that works. It sounds really convenient when you just say, yeah, it happened in a happening kind of way because it's happened. There's nothing here. You see what he said, a completely transparent assumption, etc. And he says, by cutting and pasting different bits of RNA together, okay, where did you get this RNA? It assembled itself, okay. But then when you cut and paste different bits of it together, okay, how did that happen? You know, even Jeff, with his prowess with the beads there, he, couldn't get that to kind of happen, and that was just some beads. So how do you cut and paste them together? Well, that sounds like something intentional, not random, etc. But anyway, the RNA molecules could create ever more useful sequences. Yeah. Okay, this is the level of support that we have for this. Eventually, they found a way to make proteins and protein enzymes, which proved so useful that they largely supplanted the earlier RNA versions and gave rise to life as we recognize it today. Well, yeah, again, it all sounds good unless you actually think about it. Because when you think about it, it's like, oh, whoa, wait a minute. That was a pretty big leap there. How did that happen? It just happened, and then this just happened, and then this just happened. That's pretty lucky. But there's no proposed mechanism for how any of that actually happened. I hope you see the problem there. So, that makes me ask a bunch of questions there. Every single part of his sequence here is a complete assumption, just an absolute leap, from 0 to 100% with nothing in between. You want to talk about these things that don't exist self-assembling themselves? Look, I respect good scientific inquiry, but this is not. It's good inquiry, it's not good conclusions, because there's no basis for it. Listen, I'm going to show you something ridiculous that's far more likely than what you just read there. How about on some particular Saturday, I leave this sitting in my driveway while I make the inevitable run up to Home Depot for whatever it was that I should have picked up earlier. And I let it sit there for an hour, or I could let it sit there for 20 million years. Either way, and it self-assembles into that. Do you think that's very likely? But I'm telling you, it's far more likely than what you just read a minute ago. Okay. Here's another thing, and I'll get off the detail here this just a minute, but I want you to know this. This is why things don't self-assemble, like the beads in Jeff's hands. They didn't self-assemble because you have to have a very precise string, some kind of a chemical backbone to make them assemble on. And you have to have exact enzymes and proteins that are made to, that's what they do, they're assembly proteins. And a lot of those occur in something called the ribosome, which again was discovered after the electron microscope came about. Ribosomes exist not in the nucleus, but out in the cytoplasm of cells. They're protein factories, and therefore enzyme and steroid factories, etc. The job of a ribosome, it's a little factory, a little apparatus, and it's made of proteins itself and RNA, both together. Very precise structure. And these are assembly machines. They take bits of RNA with instructions on them, and they take amino acids, and they're what strings it together. That's the factory that puts these things together. And like I said, nobody has been able to reproduce this any other way. No matter how brilliant you are, no matter how many millions of dollars of lab, nobody's been able to reproduce this process. Only living things have been able to do it, and they do it all day long. All right, you got to have a ribosome. All right, here's the thing though. Without a ribosome, you can't assemble any proteins or DNA. And you want to know, now the ribosomes are made up of these proteins. You want to know where the instructions for building a ribosome are contained? In the DNA. You starting to get the picture? Okay. You can't build a ribosome without being able to read and reproduce the instructions. You can't do that without a ribosome. It would be as if somebody from, I'll give you a minute. Well, there are a lot of people who have realized, this kind of shuts down the whole theory. This is kind of the fatal flaw. This is one of several things that just completely negates the whole idea of abiogenesis. For some of you who want later on, I'll make these files and notes available to you if you want to read that. But let me just give you, if the gravity of that conundrum, that contradiction, it's not clearly apparent, let me just give you another one of my silly nerd illustrations. Let's say somebody comes from the future to visit you, all right? Why not? And so they hand you a little device, a little chip, some type, and they said, listen, I'm from the future, and we've conquered most major diseases, and I've put all the instructions. It's real simple, I've put all the instructions to cure all of these major diseases. They're all right here on the chip. You'll be able to reproduce them. Plus, there's some really good recipes on here. A few things that haven't happened yet. So I'm going to give you this. Okay, so they hand you this chip. And it doesn't look like a flash drive or, a micro SD card or whatever. And you say, well, okay, thanks. How do I read this? Okay, and your visitor from the future, she says, oh, you just pop it into your plasma ion flux hologram reader, and it'll just come right up. And you say, well, but I don't have a, whatever I just said, plasma ion hologram flux reader. And she goes, oh, no problem. They're very simple to build, and the instructions are right there on the chip. Okay, that's what we're talking about here. You can't read the information without the exact structure, the right apparatus to do it, and the instructions for building or assembling that structure are in the information that you can't read without it. They both had to occur simultaneously, or they're both useless. Okay, so I think you're getting the picture there. All right. I'm going to skip over a lot of this too. I told you that different people are saying, well, okay, to get life from non-living things, some people say that the RNA came first, other people. Well, let me skip through a lot of this because the bottom line is within each of these groups, and there's kind of some semi-nasty, semi-respectful scientific competition that goes on between these different researchers. Hey, look, I'm all good for people trying to build on each other's work. That's how you learn things. And trying to learn something first, that's okay. But at any rate, every one of them will tell you, no, these other guys are full of garbage. Only the way I say, that's the only way it could have happened. And then the next guy goes, no, he hadn't got a clue. It couldn't have happened that way. They will all tell you exactly why the other theories are impossible. All right, but here's the thing. There's not even an exactly conjectured sequence. I showed you a minute ago. He's kind of like, well, yeah, these RNA molecules, they self-assembled, and then, they cut and pasted themselves to be more useful. And how did that happen? Whoa, we hadn't got to that yet. Okay, so every one of these, I'll give you the punchline of it. Every one of them has complete contradictions, multiple fatal flaws of reasons that they don't work. They just don't work. So all of these, here's the bottom line, there's no evidence actually, despite 70 years now since Miller-Urey, 70 years, 69 years I guess, of really good, smart, dedicated research work, there's still no evidence to support any of it happening except conjecture. no observation, no experimental. You can't get it to happen. It doesn't happen no matter what you do. You can't make it happen. So whether you say RNA happened first or metabolism or containment or whatever, you have to get all of them. And nobody can even come close to explaining even the smallest piece of it. All right. And then when you add on to that the need for a ribosome and all the additional complex structures that have to go with it, nobody can even come close to overcoming this. So it doesn't really matter what you claim happened first. The evidence, and I mean from people who are trying hard to demonstrate this, the evidence shows that none of it happened spontaneously. None of it. So the only details that are still missing are every single one of them. But aside from that, you can just assume that, yeah, life spontaneously came from non-living material. And Miller, who just, I think, died just a couple of years ago, they came back to him and said, what do you think about all this, 70 years of work that have happened since you were a young graduate student? And he kind of said, yeah, they're all full of garbage. He goes, but someday we'll find that self-replicating molecule. He said, but none of these people, they're all wrong. Every one of them are dead wrong. Anyway, you go back to Professor Hawking. Basically, don't let the total lack of explanation, the total lack of evidence, and the presence of one fatal flaw after another, don't let any of that stand in the way of just assuming, just because he said so, that it all happened anyway. But that's what virtually every single biology textbook you will ever read says. It just happened. And I want you to know, and there are people doing, again, more brilliant work for trying to figure out, okay, what did happen, because we haven't found it yet. Anyway, and there is a concerted search for a unified theory of life, as long as it doesn't involve a creator. Let's find a unified theory, but not that one. And amazingly, a lot of people are now starting to seriously suggest, okay, it just happened. Well, okay, we quit looking for the explanation. You're not going to find it, but you can just safely assume we all know it happened, so just accept that and move on. It just happened. Folks, I can't go for that. Not if you've got an honest, inquiring mind. That doesn't work. Now, you can tell me that there are things that are not explained. Sure, plenty of things. But when something is proven to be contradictory and you're telling me I'm supposed to just accept it anyway, I'm saying no way. I don't go for that. But that's kind of what's happening. Francis Crick, one of the co-discoverers of DNA, noted atheist. Okay, again, I'm not misquoting him, and I'm not taking him out of context. He was not a believer in any kind of creator. So I want to make that clear. But here's what he said. Right now, there's no other way to explain this, okay? He would not accept that there might be a creator. But he says an honest man, armed with all the knowledge available to us now, could only state, in some sense, the origin of life appears to be almost a miracle. And after nearly 70 years now of experimentation, you finally, without any evidence, just come back and once again play the multiple universe and anthropic principle, that we looked at last week. Just play that card one more time, because that's what comes out every time when nothing can be explained. This guy says, well, if you have a nearly infinite number of universes, then the impossible becomes not only possible, it becomes inevitable. That's kind of like magic, isn't it? Anything I can dream up, no matter how impossible it is, I can just say, oh, it's not only possible, it's inevitable because of millions of universes. So, and we're in the one where it happened, just by chance. Look, this is a desperate exercise in self-delusion at this point. I really admire and I promote ongoing good research. My ears are open to anything that comes along. I want to consider it all. But very much inspired by what we looked at the beginning, an a priori commitment to exclude any consideration of intervention by a superior entity and just cling to whatever is left. Well, never mind that. I'll just say, anytime that your logic is that you can just conjecture anything at all and then just deem it not possible but inevitable, there's just no validity whatsoever to that. You can just fill in the blank with anything if that's your logic. All right. And I will note once again, if you have to resort to conjecturing the existence of millions of other universes to try to get some kind of odds of these things happening in the one that we happen to be in, look, I will tell you, you have inadvertently confirmed that what you believe is actually not believable, but that you're determined to believe it anyway. Let's leave it at that. Folks, you are very kind. So on our third major question, we'll leave it at that. And next week, let's talk about evolution. Let's assume next week that we have gotten the appearance of some kind of life on Earth. And now we've got to get from, the simplest cell to you and me and everything else. Thank you for being here. Please rescue these donuts before they go bad at midnight tonight. Take one with you. I hope you have a good week ahead. Thanks, folks.
Great job.
Thank you, Tim.
One of the misconceptions that we as Christians need to make sure that when somebody asks us, do you believe in evolution? My answer is absolutely, but let's make sure we're talking about an evolution because things change.
Oh, yeah.
And so
Natural selection
I know a lot of science, and we know what natural selection and
That's
evolutionary process and
this much is absolutely true.
Right.
Yeah.
But now, do I believe in evolution and do you believe in it?
Yeah.
So everybody needs to be on the same page.
We are definitely going there. Thanks, Tim. And I think we're probably 2 weeks on evolution. Yeah.
This was fun to me today. I don't know what the rest of them do. I don't know what
To me, this is where it actually gets interesting. So, thank you, Tim.
I appreciate you listening.
Hey, thanks, Elliot. Good to see you, brother.
So I'm just wondering, how many more weeks of this do we have? I haven't been.
Yeah.
Apparently 2 more. I heard
Well,
2 weeks
what
of
I'm gonna try to do is cover evolution the next 2 weeks, and then probably a week of wrap up. So that's the plan.
Yeah, I feel like with the abiogenesis thing, it's just so improbable that it's like why even
I
the
know.
evolution part. It's kind of like like it's kicking the can down the road, so to speak.
Right. Because if you can't get this to happen, there's nothing to evolve. And this is the part nobody even thinks about. Most people have never even heard of this part of it.
Yeah.
They hear about evolution. They've never even thought about, well, how do you have anything to supposedly evolve?
Because I mean, the thing about evolution is it seems like infinitely more possible than this, just because it's kind of like, at least to me.
Yeah. Well, actually, it's equally flawed, but you'll see that.
Yeah.
So
I haven't really looked at it.
yeah, what you have, and you'll see this. It'll be very plain. You have one impossibility stacked, multiplied times another impossibility. 3 in a row. As far as the initial appearance of things, look, I can't speak to that because it didn't spontaneously create itself. But if you want to tell me, it happened somehow, I can't argue with that by itself. But then if you talk about the structure of the universe and then the appearance of life and then evolution, complexity of life, you've got 3 absolute impossibilities multiplied by each other. It's 0 times 0 times 0 is what it amounts to.
Yeah.
So anyway, thanks.
Interesting you're going over this stuff right now because I'm currently in a biology college.
Okay.
So it's kind of funny. I don't know, I've got a final and I've been trying to study more, and it's kind of funny seeing all this stuff again.
Have they covered anything with abiogenesis in the class?
No.
No, they usually give that 2 sentences. It happened. We're still figuring out how, but it happened.
I don't think we ever covered theories.
Yeah.
I don't think that.
Probably not.
Well, it wouldn't be creation, it would be
Spontaneous appearance. Yeah.
We never got.
No, and to me that's okay. If you didn't cover it at all, that's okay. Cover what you can observe. Yeah, just don't make conclusions about what you didn't cover, and throw them out there, which is.
The sentence, I feel like the sentence there might have been some sentence about the appearance of life, and it was literally like after the appearance of life. Or something.
Exactly. That's about what it'll get.
Yeah,
and they'll never show you the contradictory evidence. The next 2 weeks, you're going to see evolution laid bare and given serious, respectful consideration, because it's a clever hypothesis.
Yeah.
At least until we discover DNA. At that point, it's not even so clever anymore. But it was when he formulated it. So, but you're going to see a serious, objective look at pro and con, because it deserves consideration for sure. And of course, there are people who believe in theistic evolution. That is, that there was a God who created the universe and put simple life here, and then he let it evolve. So, that you gotta consider that.
I think you mentioned that as an alternate theory a couple of weeks ago.
Yeah, I did. Right. It was flashed up there, so it'll come up again. So thanks very much, guys. Yeah, and good luck with your biology class. You'll love it.